Good morning, class. Many engineering components have complex internal features, hollow bores, keyways, internal threads, stepped holes, chambers, that cannot be clearly shown with ordinary orthographic views. Hidden detail lines, dashed lines, can quickly become confusing when there are many internal features overlapping. Sectional views solve this by imagining that the object is cut open and the cut surface is drawn directly. Think of slicing an orange in half. You can now see the internal structure clearly. WAEC technical drawing frequently requires full sections, half sections, and correct section hatching. Today we master these techniques. A sectional view is obtained by imagining a cutting plane passing through the object, removing the near half, and looking at the cut surface. The cutting plane is shown on an adjacent view, usually the front view or plan, as a cutting plane line, a long dash, two short dashes, long dash line, with arrows indicating the direction of viewing. Cut surface hatching. The exposed cut surface, where material was actually cut, is shown with hatching, thin parallel lines at 45 degrees, evenly spaced, typically 3 to 5 mm apart. Adjacent parts in an assembly are hatched at different angles, 45 degrees versus 135 degrees, or different spacing, to distinguish them. Do not hatch through a hole. Hatching stops at the edge of the hole. Thin materials, sheet metal, gaskets, are shown solid black rather than hashed. Material not cut. Features such as webs, thin ribs, spokes, and solid shafts are not cut in conventional section, even if the cutting plane passes through them. This prevents the section from looking like a solid mass. Screws, bolts, nuts, keys, and pins in assembly sections are also not hatched. They are not cut. Full section, the cutting plane passes entirely through the object from one side to the other. The entire interior is revealed. When to use: when internal features need to be shown clearly throughout the object, when hidden lines would create confusion. Procedure for drawing a full section. Step 1. Decide where to cut, usually through the axis of holes or the most complex internal feature. Step 2. On an orthographic view, draw the cutting plane line with direction arrows labeled A, or similar. Step 3. Draw the section view, labeled section A. Step 4. Show the cut surface with 45 degrees hatching, thin, evenly spaced. Step 5. Remove all hidden lines from the sectional view. They are no longer needed. The interior is now visible. Step 6. Keep outline lines of features behind the cutting plane. They are still visible and should be drawn. Nigerian application. A sectional view of a pipe fitting shows its internal bore diameter, wall thickness, and threaded sections, all essential for a plumber in a Nigerian water supply project to order the correct component. Example: hollow cylinder. A cylinder with a bore, central hole. Full section through the axis shows the outer diameter, wall thickness, and bore diameter as visible lines. 45 degrees hatching on the two cut walls, left and right. No hatching in the hollow bore. Half section, used for symmetrical objects only. The cutting plane cuts only through half the object. One half of the view shows the external appearance, the other half shows the internal cross-section. Advantage: both external shape and internal features are shown in one view, no need for a separate external view. Dividing line: the boundary between the two halves is the center line of the object, or thin dash dot line, not a solid line. Rule: hidden lines are not normally shown in either half of a half section. When to use: symmetric objects such as shafts, flanges, housings, pulleys. Other section types. Part section, local section / broken out section. A small portion of the view is cut away to reveal a specific internal feature. The break boundary is shown with a freehand irregular line. Useful when only a small area needs to be revealed. Revolved section, the cross-section shape of a rib, arm, or spoke is revolved 90 degrees and drawn superimposed on the existing view. Used for structural members, spokes, and handles. Removed section, same as revolved section, but the cross-section is drawn alongside, not overlapping, the main view, labeled with reference letters. Section through thin material. Gaskets, seals, washers, shown as solid black fill, not hatching, because they are too thin to hatch clearly. WAEC Technical Drawing questions on sectional views. Question 1. What is a sectional view and why is it used? Answer. A sectional view is produced by imagining a cutting plane slicing through an object, removing the near part, and drawing the cut surface. It is used to show the internal features of objects, such as bores, chambers, walls, and threads, more clearly than hidden, dashed lines can, especially when internal features are complex. Question 2. Describe the hatching convention for sectional views. Answer. The cut surface is hatched with thin parallel lines drawn at 45 degrees to the main outline, evenly spaced, typically 3 to 5 mm. Hatching should not be drawn through holes or hollow areas. Adjacent components in an assembly section are hatched at different angles, e.g. 45 degrees and 135 degrees, or different spacing to distinguish them. Very thin parts are shown solid black rather than hatched. Question 3. What is the difference between a full section and a half section? Answer. A full section is produced by a cutting plane that passes entirely through the object from one side to the other, the entire interior is revealed. A half section is used only for symmetrical objects, the cutting plane cuts only halfway through. One half of the view shows the external appearance, the other half shows the internal cross-section. The boundary between the two halves is the center line. Question 4. Why are bolts, nuts, and solid shafts generally not hatched in assembly sections, even when the cutting plane passes through them? Answer. This is the conventional practice for parts that are not significantly improved in clarity by hatching, and where solid hatching could be misleading about the material distribution. Bolts, nuts, and keys are standard fasteners whose cross-sections are already known from their standard specifications. Shafts are solid throughout and section hatching would simply show a solid filled circle. The convention improves readability by reducing unnecessary ink. Question 5. On what type of drawing would you use a half section rather than a full section, and why? Answer. A half section is used on symmetrical objects, e.g. a circular flange, a pulley, a shaft with a central bore. It is preferred over a full section for such objects because it shows both the external profile, in one half, and the internal features, in the other half, within a single view, providing complete information without requiring a separate external view.